Okay, this is term 3, week 5, physics CA. Term 3, week 5, physics CA. 0 calculations questions, all memorizing. All memorizing, understanding, whatever you want to call it. Okay, كله عن nuclear energy والfission or whatever radiation. Okay, the nuclear reaction where heavy nucleus splits into two lighter nuclei, okay, is called fission. Okay, fission. There's fusion and there's fission. Obviously, from the word fusion, fusion is two nuclei producing one. Fusion would be any, look here. This is in the book they explain fission. Okay, this is fission. Fission. Whoa, why can't I write? Okay, fission. This is fission. Okay. What can I say? Okay, it produces two daughter nuclei. Okay, so if you want to see in the graph they give us, it starts as one uranium atom, okay, and they bombard it with a neutron, okay, and that neutron causes energy to like disruption, okay, it produces this krypton and this barium, okay, and then this also produces a neutron, okay. This is a chain reaction, okay. Chain reaction meaning the energy from this breaking down leads to this breaking down. See, now the krypton breaks down into this, and then these also break down into this and to this. Okay, so what I'm trying to say is it's a chain reaction. Okay, it starts off only with one atom, one uranium, and then leads to this and this, and these also have some leftover energy from behind, okay, which also causes this to break down into this and this, okay, and these break down this and this, okay, and then so on and so forth, and it's a never ending. Okay, uh, fission. Okay, that's defining nuclear fission. When a nuclei is bombarded by a neutron and it splits. See, this is the neutron, this is the nuclei, it splits. Okay, Hala, we'll go over all of these points. I'll go over them. Okay, but not now. I think next question. Question 2. Okay, what are the disadvantages of nuclear energy? Okay, I'm gonna. Whoa, it's content is blocked. But it was working. Wait. Thank you. Okay, disadvantages of nuclear energy. I'm going to go through both advantages and disadvantages. Okay, obviously I'm not reading all this. Okay, that's too much. Okay, but we're going to start with advantages. Okay, the first thing about the nuclear energy. Okay, it has nothing to do with the greenhouse effect. Okay, so look here. We'll start with the first advantage. Nuclear energy, basically what happens is there's a nuclear reactor and they use fission. Okay, fission is when they break down these uraniums, okay, and when they break it down it releases like a lot of energy. So instead they do this, like nowadays countries are using this instead of using fossil fuels and burning them, because fossil fuels release too much pollution. Okay, so let's start. Burning fossil fuels produces huge amounts of carbon dioxide and contributes to the greenhouse effect. Okay, carbon dioxide accumulates in the air, okay, blah 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 blah. It causes the greenhouse effect. Okay, in short terms, okay, what most industries do, they'd say, okay, this is coal, I'll use it in black. Okay, this is coal. Okay, they burn it, put the fire in it, they burn it, right? Okay, whatever, they burn it. It releases some gases. It's gonna release CO2, okay, carbon dioxide. This carbon dioxide is very harmful, okay, it's harmful. أول شيء because it causes the greenhouse effect. Okay, the greenhouse effect is basically global warming. In simple terms, that's global warming. For those of you who don't know what global warming is, it's basically our planet getting hotter. Okay, the temperature of the planet is rising. Okay, so burning fossil fuels would cause the greenhouse effect. Obviously, what does this have to do with radiation? Okay, what it has to do with radiation is nuclear energy, or sorry, radiation. I'm saying the nuclear energy that we're talking about. What does this have to do? Because nuclear energy, instead of releasing carbon dioxide, it produces no exhaust gases. Okay, so nothing burns, so it's a clean form of energy. So it has nothing to do with the greenhouse effect. Okay, that's advantages. Sure, come on. They said fossil fuels also contain sulfur. Okay, when these fuels are burned in air, it causes acid rain. Where is it? It should be somewhere here. Acid rain, yeah. So again, the same coal, okay, once you burn it, we said it releases CO2, right? Okay, for global warming, okay, and it also releases sulfur. Let's just call it S. Okay, this sulfur causes acid rain. Okay, so basically This is the fossil fuels. Okay, FF. We don't want this. Okay, so the advantage of a nuclear energy is that it doesn't cause acid rain and it doesn't cause global warming because it doesn't release any gases. Okay, then the last advantage is that fossil fuels can run out, but شو اسمه uranium, there will never be a shortage of fuel. Okay, because we produce our own fuel, which is plutonium. Okay, for nuclear reactors. Okay, fossil fuels run out, but our nuclear reactors will never have a shortage of fuel. Okay, then the disadvantages. The first disadvantage is that it costs a lot. Okay, why does it cost a lot? Because they have to build these walls. If you see over here, they're very thick. Okay, they cost a lot. Why they're very thick is because uh, to encase the core. Okay, to encase the core, to protect the people working at the nuclear power station, because there is radiation inside here. Whenever you have anything nuclear, that means there's radiation, and radiation is very deadly. Okay, radiation. Okay, it's very deadly. So they need thick walls. So they have to pay a lot of money. Okay, to produce those thick walls. Even once they pay a lot of money, some radiation may seep through the walls. Okay, so that's why they wear protective clothes for the people who work at these power plants. Okay, so lots of protective material is needed, and this costs a lot of money. Okay, next disadvantage, it produces radioactive waste. Okay, radioactive waste. Uh, the materials in the core will eventually become spent or used up, will need to be replaced, although they are low. Okay, blah 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 blah, because the byproducts. Okay, these materials together with other. Okay, yeah. So basically, let's say you have the reactor. Okay, this is the reactor, and I have uranium inside. Okay, after what? Let's say every year. Okay, you have to like change out the reactor, right? No, خلاص, these uraniums are done. I have to fill it up with more uranium. Okay, so what do you think happens to the products that are left over in the reactor? Obviously, we're gonna throw it away because خلاص, it's waste. Mash it feedna. It's not really beneficial to us anymore. It's not giving us any more energy. So we're gonna clean it out and we're gonna take those wastes out. Okay, but these wastes are radioactive. Okay, radioactive meaning it has radiation. So why is this a disadvantage? So what they're genuinely, it's a disadvantage because يعني, once they have these wastes, they're now carrying a huge pile of radiation, and we don't know what to do with it. So what they do with it is they bury it deep in mines, in solid concrete, in places where it cannot contaminate water. Because if these wastes somehow find their way into rivers, or somehow find their ways into drinking water, or find their way into the beach, many people will die. Okay, because it will cause radiation and many people will get cancer and die. Okay, that's the harms. What it causes is another chapter. We will see that in a bit. Okay, physical psychological bias. Okay, people are scared of nuclear accidents. Okay, after Chernobyl, blah 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 blah. Okay, because there was this one time there was an accident. Okay, uh, what happened was some radiation seeped from the reactor into the air and exploded, and then many people died. Okay, a lot of people died in Chernobyl. Okay, radiation contaminated the air. So after the explosion, there still remained radiation. Hatta until this day, if you were to go to Chernobyl, okay, you'd still find radiation. Obviously, it's not as much as back then. It was in like 1972 or something. But what I'm trying to say is there's always going to be radiation left over. Okay, these are yeah, خلاص. These are the disadvantages. For what are disadvantages? Okay, radiation can seep through the environment. Remember we said that. Do we say they pollute the environment with greenhouse gases? We said no. The nuclear energy actually doesn't contribute to the greenhouse effect. The half life. Oh, and I didn't talk about the half life. Where was it though? It's somewhere here. Okay, yeah, yeah. Some have a short half life. The radioactive materials. Okay, if it has a short half life, that means يعني خلاص, after we bury it next year, خلاص, we're done. It's not going to be there anymore, and it's going to keep on decaying. Remember, a half life basically because each nucleus tends to break down into half its amount. That's what we call the half life. If it has a short half life, خلاص, it's chill. But however, most of the nuclear power plants, they have half lives that measures in hundreds or even thousands of years. So that contributes even more to the difficulty of getting rid of the nuclear waste, because its half life is so long that it takes too long to get rid of it. Okay, so the half life is long. Okay, We didn't say they pollute. No, nuclear plants contribute to global warming. I said no. The greenhouse effect and global warming, it has nothing to do with it. And is it a large amount of fuel required to run a nuclear plant? No, it's not really. It's just the uranium. That's literally it. Okay, and maybe then neutrons, but that's not important. And I'm talking a lot. We're 10 minutes in. We're only 2 questions in. But I had to read the book because it makes everything way easier. Okay, I just you guys could have skipped through it. Whatever. بس يعني I like to explain for those who really appreciate the explanation. And what am I saying? المهم, what are now advantages of nuclear energy? Okay, did we say there's psychological bias? Is that an advantage? Obviously not. Psychological bias basically means people hate it. Okay, and people really don't like nuclear energy, especially with the previous accidents. Did we say it can be built everywhere? Obviously not. Obviously it can't be built near the city. If it has radiation coming out of the power plant, how is that? How does that allow it to be built beside the city? It's just going to kill everybody. Uh, it does not contribute to the greenhouse effect. We said it does not contribute. Power plant does not require protective material. That's wrong. We said that it takes a lot of money to build the protective material. Does it run on a smaller amount of fuel compared to coal plants? Yes. Remember, coal is a fossil fuel. Coal is a fossil fuel. Okay, and that needs a lot of fuel. Okay, but our nuclear energy doesn't require, because like it was in the book here. They said somewhere here. Yeah, here. So a coal uh, a coal factory would need 10,000 tons of coal, okay, every day, okay. However, a nuclear power plant that uses uranium would only need 1 kilogram. So this is actually 10 million times more than the uranium. So just put that into perspective, yeah. Question 4. Okay, this is all memorizing this part. Okay, internal energy. So you have three types of energy. Okay, you have random thermal energy is found in the particles of a body due to the random motion. Okay, just random thermal energy, random motion. Okay, in addition to random thermal energy, the molecule of an object possesses potential energy. Okay, there's not only one type of potential energy, there's many types. Okay, you have intermolecular potential energy. So look, between, let's say this is the blue molecule, the blue circles are water. Okay, they're H2O. So this is one water, it's another. Okay, and they form bonds, right? Like for example, this is a cup of water. They're all stuck together, the water bonds, right? This would be another water, whatever. Between these bonds, there is some potential energy. Okay, this is what we call intermolecular potential energy. Okay, so it's basically the potential energy due to the position of the molecules. Okay, for example, an object contains mostly intermolecular potential energy when it is in the gaseous state. Okay, the further away, because these are all questions that could come, the further away the molecules are from each other, like this is over here in a liquid, but when it's a gas, they're very far from each other. Like here, when it's a gas, when it's water vapor, because water vapor is the gaseous form of water, there is more potential energy here. Okay, there's more potential energy, and since it's between molecules, we call it intermolecular. Okay, intermolecular. Okay, chemical potential energy, okay, is uncombined mixture of, okay, blah 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 blah. That's chemical potential energy. They're gonna talk more about the chemical potential energy in a bit, but just keep that in mind. There's also chemical potential energy, and then there's internal energy. Okay, the internal energy of any body, okay, is equal to three things. Okay, you add the random kinetic energy, the intermolecular potential energy, and the chemical potential energy. So internal energy, we call it IE, is equal to the random kinetic energy, okay, plus what's it called, the intermolecular potential energy, IPE, plus uh, the chemical potential energy, CPE. Okay, and that's a question here. What is the internal energy equal to? The random kinetic energy plus the chemical potential energy plus the intermolecular potential energy. Okay, very easy. Question 5. Okay, I think now they ask about, okay, what are the harmful effects of radiation? We'll go through them all one by one. Okay, this is the applications, the good part. I think it's down here. Yeah, the dark side of radioactivity. Okay, we'll go over these quickly. Very high doses of radioactivity can cause death. Okay, very simple. Lower doses of radioactivity may cause leukemia. Leukemia is blood cancer. Okay, blood cancer. Okay, within 2 years, or other forms of cancer. So it causes cancer. Radiation can also cause genetic aberrations. Okay, like the genes mutate. For example, I think some people after the nuclear bomb in Hiroshima, they had some mutations where like they became blind all of a sudden. Why? Because of the radiation. The radiation can do stuff to your body. Okay, so that's what we call genetic aberrations. So it changes stuff in your body. And then the damage resulting from radiation results in loss of hair and sores that take a very long time to heal. Yeah, also, again, after the Hiroshima bomb, for those who survived it, the radiation did cause people to become bald and lose hair, both women and men. Uh, okay, this is blah, 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 blah. Okay, so what is one harmful effect? Cancer. Okay, there was other stuff like soreness and stuff. I don't, I think. Okay, what is true about fission in a nuclear reactor? Okay, the first one, we need neutrons for fission. Okay, the amount of energy produced cannot be controlled. No, that's wrong. You can produce, you can control it. You can control how much uranium you put in the nuclear reactor. Obviously, you can control it. The breaking of nuclei is spontaneous. No. Okay, it stops eventually. The nucleus may split into different combinations of daughter nuclei. Yes. Electricity can be produced from the heat given off by the reactor. Yes. Aslan, what's the whole point of the nuclear reactor? Is to produce electricity for us. Okay, and these all come from the book over here. They're all points here. So, for example, although fission can, well, although fission, oh, although fission can occur spontaneously, each fission is caused by neutrons from a previous fission event, and therefore it is not spontaneous. Okay, unlike radioactive decay. Since each occurrence of fission, blah blah blah, they call it a chain reaction. This could come. Okay, what is it called? It's called a chain reaction. Okay, in a nuclear power plant, also energy is controlled. Okay, and heat from radioactive decay is seldom significant and not controllable. That's something else, but it produces heat. Okay, what else did they say? Yeah, it produces different combination of daughter nuclei. Okay, question 6. Which ones contain chemical potential energy? This is all from the book. And I didn't know all of this until I read the book. Radiation. Okay, obviously it goes from hot to cold, whatever. What's this? Okay, it's just, yeah. Okay, you can read this alone if you want. I don't, whatever. Okay, the second law of thermodynamics. But chemical energy is what I'm looking for. Chemical energy, okay, it's found in chemical fuels, so fossil fuels. Okay, fossil fuels, and also food. Okay, that's pretty much it. Yani. Fossil fuels and food. Question 8. Detecting the leakage. Okay, again, and I'm going through all of this because I'm not going to read through all of these because that's too much. You guys can read through it on your own. But I'll go over the summary. Okay, how can radiation benefit us? It can trace the path of a reactant in a chemical and biochemical reaction and in industry. Okay, so let's say you don't know where something is coming from, you can use tracing, radioactive tracing. Okay, so it can help you trace something. It can measure the thickness by using penetration. Okay, because مثلا, if you have a sheet of paper and you bombard it with alpha particles, okay, you can test if the alpha particle makes it through, then you can conclude that this sheet of paper is less than 5 millimeters because the alpha particle has penetration power of 5 millimeters. These numbers you don't have to know. This is just an example. I'm just showing you how they test it to measure thickness. Okay. Radioactive dating, as the amount of substance left undecayed is related to age. So if you were actually for the ancient Egyptians, how they found out, they give you numbers. This was 4,000 years ago, 5,000 years ago, and you'd ask, how'd you get these numbers? They actually use radioactive carbon dating, and basically what it does is let's say they found a paper, okay, an old manuscript or whatever from Egypt, okay, and they would say, how old is this? The scientists would test it, okay, and they'd see how much carbon 14 is in it. Okay, if there's less carbon 14, that means it's older. Okay, if there's only a little if there's a lot of carbon 14 still, then that means it's new. Why? Because yani, as time goes on, the carbon 14 decays. Okay, so the less carbon 14, that means there was more decays, that means there was more time for it to decay, that means it's just an older sample. Okay, and then one more, medicine to kill cancer cells. So sometimes Sometimes when people have cancer, okay, they can't remove the tumor using surgery. So what they do is they bombard it with radiation. They use radiation, and the radiation will kill those cancer cells and those tumors. Luminous scales by coating a source of fluorescent materials. Okay, like glow sticks, for example, are actually forms of radiation. That's why they always tell you don't eat a glow stick because I think you die. I'm not 100% sure. But glow sticks, I think you guys all know what glow sticks are. Those have radiation inside of them. Food irradiation and insect control. I don't know. Ah, yeah, food irradiation. So like nowadays, they use radiation to kill the bacteria on food so that they can preserve it for longer and like put it in cans and stuff. Okay, and also insect control, same thing. Insect control, what they do is, for example, they did this in Singapore. Okay, there was too many mosquitoes. What they did is they took a mosquito, they played with it in the lab a bit. Okay, the process is advanced, but just in summary, they played with the mosquito in the lab, they added some radiation to it, and basically they released it back into the wild. And what happens is, when that radiation goes when that mosquito goes back out into the wild and it mates with another mosquito, it kills that mosquito, because it has they no they it adds radiation to the mosquito. So like what it does is it kills now other mosquitoes. So that's how they control insects. You don't really have to know that. But المهم, detecting the leakage, or if I want to detect anything, I can use radioactive tracing. Tracing means to find the source of something. Okay, question 9. Measuring the quantity of carbon 14 left in a bone is how you determine its age, how old it is. Its age. Question 10. Okay, what are some side effects of using radiation to treat cancer? Causing healthy cells to die and causing healthy cells to become cancerous. Okay, I didn't explain this. It's in the book. I'm not going to go back and read that part. Okay, but why some people they choose not to use not to use radiation in treating cancer is because this radiation will end up also having some side effects on your body. It's not all fun and games and خلاص, oh, I killed the cancer cells, خلاص, I'm good. No, it's also going to spread that radiation to the cells beside those cancer cells, even if they were healthy, and they would cause those healthy cells beside the cells you just killed to become infected with radiation and get cancer. Okay, so it caused some healthy cells to die, and it may cause them to become cancers. Okay, question 11. Oh, I went to 12. Okay, an important factor that must be taken into consideration when safely burying the nuclear waste is the half-life. Remember, we said that some nuclear wastes have shorter half-lives, but most do end up having longer half-lives. Okay, so when burying it, they take that into consideration. Question 12. Why is the concept of, okay, whatever, okay, because it helps predict changes to objects caused by the interactions. This is all here, chapter 8. Okay, energy. I mean, this is all, yani, you should know this from grade 5. Energy is the ability to cause a change. Okay, blah 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 blah. This is too much, too much, too much. Yep. Okay, because it helps to predict changes to objects caused by their interactions. Just memorize that. Question 13. What is the term that best describes the ability to cause a change? Obviously, that's energy. I'm not even going to explain that. Question 14. Okay, so they're saying sunlight causes a tree to grow and energy gets stored in its leaves and stem. This energy can later be restored by burning the tree. Okay, complete energy chain transmission. So our sheet starts at sunlight energy, right, which is radiant energy. If they said light energy, that would also be correct, or maybe solar energy, that would also be correct. But radiant is the same as light. So it starts with the sunlight. And the plant does photosynthesis, right? I think all of you in grade 10 know what photosynthesis is. It makes sugar, right? So it converts this energy into chemical energy because it became sugar, okay, after the photosynthesis. So now it's chemical energy. Okay, and then what happens after the chemical energy? We burned it, right? We burned the tree, so obviously it's being released as thermal energy. Thermal energy is like heat energy. Okay, heat energy. That's it for Physics CA. Thank you so much for watching. I know I over explained a bit. Good luck.